Good evening. I thought I would spend a couple of minutes tonight answer a couple of questions you might have on some of the area between curve problems that were assigned in section 6.1. So I've selected two problems for this video, and then I'll do another question in a second video. But we'll get these two out of the way, and then we'll see if we can get to the third one, and that way you can maybe be watching this well, if you get on it real quick while I'm doing the third one. So I'm going to start with problem 18. Problem 18 says y equals 8 minus x squared. Now, that's a parabola that opens down from y equals 8 to it crosses the x-axis at plus or minus 2 root 2, I believe, is where that would cross the x-axis. We also have y equals x squared. That's our standard parabola. And then we have the two lines x equals 3 and x equals negative 3. I picked this problem because I know there's a lot of Star Wars fans out there, and the drawing turns out to look like, well, you know, I don't know if you remember what an X-Wing fighter looked like or not, but for all you Star Wars fans out there, maybe it looks a little bit like an X-Wing fighter. So this is the picture. You can hit pause here if you wish on your video and take a second and draw the picture. Hopefully your picture looks something like my picture. Now, you'll notice a couple of things about this graph. First of all, we have symmetry. We only have to figure out the area from the y-axis over to x equals 3, and then just multiply that by 2. If we do that, we'll eliminate having to figure out, say, the integral from negative 3 all the way to positive 3. Now, the other thing you need to notice is that we're going to need two separate integrals to work out this problem. Again, if we just focus on the portion of the graph from 0 to positive 3, the integral from 0 to 2, if we're talking in terms of x, and here I'll draw a representative rectangle here. Let me see if I can find another pen, something in a different color. If we draw a representative rectangle and then another representative rectangle further to the right, we end up with something that looks like this. Now, our first representative rectangle, the one that is basically, I drew it at about x equals a half. That representative rectangle, the top function is the blue parabola, 8 minus x squared. The bottom function is the pink parabola, y equals x squared. But if we cross over x equals 2, you'll notice that now the top parabola in that area is the pink one, y equals x squared, whereas the bottom parabola is now 8 minus x squared. So when we formulate our expression for the area, we're going to have to take into account, remember, the area is top function minus bottom function. So if we're going to try to write down this parabola, this integral, the first half, the first portion of the area between 0 and 2 on your graph, if you look at that, you're going to integrate between x is 0, y is 2. Again, we're going to use symmetry here, so we're going to multiply by 2 when we're all done. But we're going to integrate from x is 0 to x is 2. Our top function is going to be 8 minus x squared minus our bottom function, which is x squared. Now, dx. That's the integral that's going to give us the area of this portion right. Whoa, where are you? Everything's backwards. Right here. This area right here. 0 to 2. Now we've got to do this area over here. Now that's going to be from 2 to x equals 3. So that's going to be a different integral. That is going to be the integral from x is 2 to 3. Our top function there is x squared. And from that, we're going to subtract the bottom function, which is 8 minus x squared dx. Now, don't forget, this is only half the area, so we're going to multiply this entire thing by 2. So my area, the final integral for the area is going to look like this. Okay. So again, you can hit pause here, look at that, make sure you understand that that's top minus bottom, and then we switch the players, but it's still, the second integral is still top minus bottom. So if we were to simplify this, this is going to be 2 times the integral from 0 to 2. And that's now going to be 8 minus 2x squared dx plus 2 times the integral from 2 to 3 of, well, that's going to be 2x squared minus 8 dx. So if we integrate that, that will get us, the integral of 8 is x, 8x, so that's 8x. The integral of 2x squared, we add, so that's 2x cubed over 3, so that's going to be minus 2/3 x cubed. Now we're going to evaluate that between x is 0 and x is 2. Don't forget to multiply by 2 due to the symmetry. Plus, integrating this, well, that's the same components for that integrand, but the signs are different. So we first integrate 2x squared. That's going to get us 2x cubed over 3. The integral of negative 8 is negative 8x. And we're going to evaluate that between x is 2 and x is 3. So you should, once you were done integrating, have come to something that looks very much like this. Again, a great place for the pause button. Now, evaluating this, we have 2 on the outside. We place 2 into the first term. 8 times 2 is 16. Minus 2 cubed is 8. 8 times 2 is 16, so that's minus 16/3. Now, when we put in 0, that's going to be 0 minus 0, so I'm not going to deal with that term. Plus 2 times. Again, up here we put in 3. Now we got 3 cubed, but we have a 3 on the bottom. So we have 3 cubed is 27 divided by 3. That's 9. Times 2, so that's going to be 18. That's just 18 there. Minus, we put 3 in, minus 8x, that's minus 24. Now, we're going to have to worry about what happens when we put in 2. So when we put in 2, we get 2/3 x cubed. You've already done the arithmetic here, so that's going to be 16/3. And we put in 2 to minus 8x, that's going to be minus 16. Now, if we take a look at what we have, everything's going to get multiplied by 2. So that's going to be 32 minus 32/3 plus 18 times 2 is 36 minus 2 times negative 24 is negative 42. Really? It might be negative 48. Negative 48. That sounds a little bit better. And then we've got 2 times 16/3, so that's going to be minus 32/3. And then 2 times negative 16 is going to be plus 32. So when we add all of this up, the negative 42 and the positive 36 give us negative 7. Negative 7 plus 32 is going to be 25. 25 plus 32 is going to be 57, so that's going to be 57. And then we have minus 32/3 minus 32/3. So that's minus 64/3. So if we convert everything to thirds, 57 in terms of thirds is 171/3. Minus 64/3, and that works out to be 107 over 3. I don't know if that's right or not. Let's take a look at the answer book. Well, I've got real bad news for you. I don't even think that's right. We made an arithmetic. I see why I said we made an arithmetic mistake. How'd you let me make an arithmetic mistake there? So let's see. 3 cubed is 27. 27 divided by 3 is 9. 2 times 9 is 18. 18 times 2. Oh, yes, yes. 18, 24, 16, 16. 16 minus 16/3 plus 2 times 18 minus 24 minus, well, you know, we did that part right. So that's 32 minus 32. Let's see. So how did we end up with, let's see what we got here. We got 32 minus 32 thirds, 2 times 18, 36, 2 times 24, 48. I did it with 42 again. Oh my goodness. There it is right there. So let's see. 36 take away 48 is negative 12. Negative 12 and 32 is 20. 20 and 32 is, it's not 57, it's 52. 52. Yeah, that's what it's supposed to be. Sorry about that. So 52 minus 64 thirds is going to be 152 times 3. So 156 minus 64 over 3 gets us to 6, take away 4, 92 thirds. 92 thirds. And that's the correct answer, 92 thirds. So, sorry about that little arithmetic mistake at the bottom there. Here, I'll hold this up with the arithmetic mistake in it. And that way, if you want to hit pause and take a look at the arithmetic to check your arithmetic, you're more than welcome to. All right, so that was number 18. Now, the next one we have to work on is number 24. And just like number 18, number 24 is going to require two different integrals. I've already drawn the graph. You'll notice that there's the graphs are y equals cosine x. That's the blue graph. And then we have y equals 1 minus cosine x. And that's kind of the orange scribbly graph there at the top. So you'll notice that the first thing I did down below is I had to figure out where the two graphs intersect. I didn't label it on the graph, but I did the work. I set 1 minus cosine x equal to cosine x. That gives me 1 equals 2 cosine x divided by 2. When does cosine equal a half? And I did the work just like we did back in the day, even though hopefully all of us know cosine equals a half at pi over 3. So that intersection right there is pi over 3. Okay, pi over 3. So our two integrals, our first integral is going to be the integral from 0 to pi over 3. On top there we have cosine x, so cosine x minus the quantity 1 minus cosine x dx, plus, for the bigger area, for the area here, we're going to have to, flip. The 1 minus cosine is on top, so we're going to have to go 1 minus cosine x minus the bottom graph cosine x. So that integral is going to be between pi over 3 and pi, and there we're going to have 1 minus cosine x minus cosine x dx. So this is what your area should look like. Now if we simplify that, that first integral is the integral from 0 to pi over 3 of 2 cosine x minus 1 dx plus the integral from pi over 3 to pi. What, can you hear that in the background? This is Rainier setting the table for dinner. I'm trying to hurry. This is going to be 1 minus 2 cosine x dx. All right, so here we go. We got to integrate this. First, we integrate 2 cosine x, the integral of cosine. Do you remember the integral of cosine? What is the integral of cosine? Sine. That's correct. So that's going to be 2 sine x minus the integral of 1. That's just minus x. That's going to be between 0 and pi over 3. Plus, the integral of 1 is going to be x. We're working on the second integral now. The integral of 1 is going to be x. The integral of minus 2 cosine x is going to be minus 2. The integral of cosine, still sine, isn't it? So that's sine x. And that's going to be between pi over 3 and pi. All right. So now we got to plug everybody in. If you don't remember what the sine of pi over 3 is, sine of pi over 3 is root 3 over 2. So that's going to be 2 times root 3 over 2 minus, and that's just pi over 3. Now, be careful with these trig problems, because when you plug in 0 with the polynomials, you always know you're going to get 0. But with the trig problems, not necessarily is that going to be the case. Now, here we have sine of 0. Sine of 0 is 0, so that's fine. And then we have minus 0. So we don't need to plug in 0 there because it turns out to be 0. But now working on the second expression over here, we have plug in pi, we get plus, we get pi minus 2 sine of pi. Okay, well, if you don't remember what the graph of sine looks like, just draw a quick sketch over here and you'll remember real quick that the sine of pi is 0. So that's pi, plugging it in for the x, minus 2 times 0, so that's 0. Minus whatever we got when we plugged in pi over 3. So we plug pi over 3 in for x, that's pi over 3. We plug pi over 3 in for sine x. Pi over 3 is opposite over hypotenuse, so that's root 3 over 2 again. So that's going to be 2 times root 3 over 2. So that gets us this. Now, we're going to have to do some arithmetic here. 2 times root 3 over 2 just gets us root 3. 2 times pi over 3 gets us minus 2 pi over 3. Plus pi minus pi over 3 plus root 3. So when we combine those root 3's, we get 2 root 3. And now what do we have? Let's see. We've got negative 2 pi over 3 minus pi over 3. That's negative pi. Plus pi, that's 0. So our answer appears to be 2 root 3 for problem 24. Let's take a look and see what we get. Yeah, another silly mistake. I'm on fire tonight. I shouldn't do this right before dinner when I'm thinking about food. So, if you'll take a look here, this 2, this should not be a quantity. If you look above, it's 2 sine x minus 1x. Well, when I wrote it down below, I wrote the root 3 over 2. And then I wrote minus, and then I wrote the pi over 3 inside the quantity. So down here I had a minus 2 pi over 3, where I should have a minus 1 pi over 3. So minus 1 pi over 3 plus pi minus pi over 3. That gets me a plus pi over 3 right here at the end. Wow, 0 for 2. Good thing that I turn off the comment section on these videos. All right, so there's problems 18 and 24 in their entirety. Corrected, mind you. I will do problem 28. See if I can get that one right. I'll do problem 8 here on the next video. All right, hope this helps.